Hello everyone, welcome back. Today in this video we will discuss alpha decay and Q value. This concept is from nuclear chapter. So here a heavier nucleus or unstable nucleus like uranium will disintegrate to a product nucleus or daughter nucleus we can say. Along with that, one helium nucleus will come out as the product. So this type of uh, disintegration or decay is called alpha decay. So here let us discuss, write the general expression for alpha decay. Let us say X Z A, Z is the atomic number, A is the mass number. It will disintegrate to Y, whose atomic number will be Z minus 2 and mass number will be A minus 4. This is general type of alpha decay where I am writing, plus a helium nucleus 2 4 will come out. So this is the general expression for alpha decay. Such type of decay are called alpha decay. For example, we will take one example: uranium unstable 92 238, atomic number 92, mass number 238. Mass number you know, atomic number plus neutron number, that means proton number plus neutron number. Atomic number is the proton number. So here it is atomic number Z. Uranium will disintegrate or decay to a newer element which is thorium 90 234 plus a helium, because you see 90 plus 2 92, right, and 234 plus 4 mass number and your atomic number, the proton number, both are balanced here, right. So this type of integration are called alpha decay. Now we will discuss about Q value. What is Q value? A Q value is the mass energy difference of the reactant and the product, because now we see if uranium will have the sufficient energy, right, or uranium mass energy will be greater than the product mass energy, then that extra energy will help the uranium to disintegrate, right, and that extra energy will be released also. So such type of decays are basically exothermic in nature. So heat energy or some energy is released in this process. That means the reactant, the left side energy must be greater than the sum of the mass energy of the right side, right. Now if the mass energy, suppose uranium mass energy, mass of uranium 92 238, mass of uranium into C square, this is the mass energy, mc square, we know Einstein mass energy equivalence, right, E equal to mc square. So mass of uranium into C square, this is the mass energy of the reactant, minus let us say the sum of the mass energy of the product is thorium plus helium. So mass of thorium 90 234 plus helium, mass of helium 24, both square, mc square. So if this energy plus minus the product energy, if we will subtract, if we will get a positive number, that means the initial energy is mass energy is more than the product. So the initial energy that will be released, because product has less amount of energy. So due to the conservation of energy, that energy will be released as a heat or some form of the energy, or that energy will be used for the kinetic energy, means they will be splitted with some velocity, this smaller nuclei will come out with some speed after that disintegration. Now if the Q value, this is Q value. If the Q value is negative, then what will happen? That means the initial energy, the reactant part, the nuclei, heavier nuclei, the energy is less than the sum of the product. That means you need more energy, right? You need more energy, you need some amount of energy to be given to the reactant, so that the disintegration will start, decay will start, right? Here the product energy will be more. So in such type of, generally these are endothermic in nature, so we have to provide some energy to start, to for the decay to start or the decay to progress, right? So one example let us take. So if uranium 92 238 will disintegrate to protactinium Pa 91 237 plus hydrogen 11. Now such type of reaction, here if we will this is an example of a negative Q value, or it's a, you have to provide some energy to the uranium so that this integration will start, right? This type of integration will start. So you can calculate it. If some numericals will come, I can leave you a question, you can try this question. So the question is that uranium 92 238, the mass of uranium 92 238 is, it's 238.05079 U, or AMU you can write, atomic mass unit, and mass of helium 24, it's 4.00260 U, you can write small u or AMU, and mass of thorium 90 234 is 234.0404. This is the question. 234.04363. You are saying, you might think that why you are taking so much number, because the variation, the difference will be very small. Only when we are multiplying c square we will get a large number. So its mass is this one, and hydrogen 11 mass of hydrogen 11 is 1.00783 U. Mass of protactinium Pa 91 237, it's 237.05121 U, right? So all the masses I have given. Now the task is, you can find out in both the cases for alpha decay, you will check that using these masses you will get a positive value. That means for this is, let's say, case 1 and case 2. So in both cases you calculate the Q value. This is your task. So how will you calculate Q value? As the formula says, just product mass energy. That means suppose for case 1 you are calculating product reactant mass energy minus product mass energy. So reactant mass energy is uranium 92 238. The mass energy is 238.05 U. If you want to convert it into MEV, right, or EV, so multiply with 931.5, so it will become MEV. 1 U is, you can convert 1 AMU to multiplying C square, you will get 931.5 MeV. So this is your number. So it will come common basically, so you can take common also. So this is your 238.05 minus, you add them, these two you add them, helium, thorium and helium, So 234.04363, here I left something, 05079 plus uh, plus you can say helium is 4.00260 and it's also 931. So you can take common or final, you can multiply with the final result after the subtraction, because 931 will come common. So if you will add this and subtract from here, the number you will get, I am directly writing, you can use a calculator or you can just by hand multiply and write, you can check that the number will come as 4.25 MeV, M is mega, 10 to the power 6 eV electron volt. So this Q value is, it will come positive number. So 234 plus 4, 238 and 0.04363, so it will come 0.45623 like that if you will add this. So 238, this is 0.5, but you will get 0.4. So just in the second digit you will get some number, that is right, something you will get 0.00 like that, some number you will get, then you will multiply with 931, you will get this number 4.25. So basically my point is you will get a positive number. So positive Q value you are getting, that means here the disintegration will be spontaneous in nature and the energy will be released, exothermic type heat will some energy will be released in this decay. But here in case 2 I am leaving you to calculate the Q value. So you just add these numbers for protactinium and hydrogen, all the masses are given, add them, subtract from this number uranium and C square, in place of C square you just multiply 931.5. How also, if you need I can explain. 1 AMU or U simply is atomic mass unit. So if you want to convert into energy, so energy if you will convert this mass into C square will be your energy, right, AMU into C. So you can write this 1 AMU is basically the mass of one hydrogen. So you can use 0.00783 multiply by C square. C square is 3 into 10 to the power 3 into 10 to the power 8. So if you will multiply 3 into 10 to the power 8 whole square, and this one is mass of one hydrogen atom, basically proton. So you can use 1.007 or 008, you can multiply 0.783. If you multiply, this number will come 931.5. This number will not come, it will come in joule. So you have to divide your 1.93, you have to divide 1.67 into 10 to the power minus 19, so that it will come in MeV. So it will basically joule. Now you have to divide this with 1.67 into 10 to the power minus 19. After the division it will come in EV. The answer will be 931.5 EV, MeV, right, 10 to the power 6 MeV. So this one is coming as the energy of one proton energy or one AMU, right. So that's why we can convert if any number is having some AMU and multiply by C square is there. So you can directly multiply 931 and you can convert this AMU to the answer in MeV, because mostly in high energy physics, nuclear physics or high energy physics, basically elementary particle physics, we use the unit EV, MEV or EV, right. So this is the Q value and this is the alpha decay. In the next videos I'll discuss beta decay, gamma decay and nuclei other like fusion, fission, the half life. Let's see, if possible I'll make one short video. So thank you for watching the video. If any of the step is not clear, you can write in the comment box so that I can make a separate clarification video. If possible I'll reply to your comment. Thank you.